Okay, so we're going to be solving polynomial equations today, and we're going to do this using the same methods that we used when we were solving quadratic equations by factoring, because we're going to be doing factoring. I want to go down to the bottom of the page here and take a look at the factoring methods that we had learned before. Well, some of them we learned before. There's a couple that are new today. One of the first methods that you used, and this should always be step one whenever you're factoring. Step one. Factor out the GCF. If there is a greatest common factor, factor it out first. It will make everything else after that so much easier if you do it first. So here is an example. This particular polynomial, you can factor out a 5x squared first, which gives you, look, a nice quadratic that you can factor using the box method or slide and divide or grouping. Quadratic trinomials in the form ax squared plus bx plus c. Remember doing these? This is where you would want to use your box method. Or slide and divide, or if you were using the grouping method. Alright, so if you had a polynomial such as this, you could use one of those three methods to find the factors of that polynomial. Now, I know that some of you shy away from getting too cozy with these particular formulas, but they're great when the numbers are big because it's a lot easier than the box method or slide and divide. Here's an example of each of these. If you get used to this method, you'll find that it is very easy and quick, and you can use it instead of the box method or slide and divide, and it's a lot faster. This difference of squares, so a squared minus b squared factors to a plus b, a minus b. This is something that a lot of you missed on the test. Here's one, 4x squared minus 15. Let's do an easy one here. How about 4x squared minus 25? This would be 2x plus 5, 2x minus 5. But you can see you can easily do this with a 15 because what you're looking for really is the square root of 15. So 2x plus the square root of 15, 2x minus the square root of 15 works really easy. This is something that we haven't covered since Algebra 1, factoring by grouping. That's when you have four terms. And the way that you would work this is you're going to take your four terms like this, and you're going to make two groups. And if you have a negative there in the middle, make him go inside. Put a little plus inside of there. Go to your first group. Your greatest common factor is x squared, so pull it out front, and it leaves x plus 2. From here, the greatest common factor, you can pull out negative 3, and that leaves x plus 2. Now your greatest common factor is x plus 2, and that leaves x squared plus 3, so x squared minus 3. So x squared minus 3 comes from here. The x plus 2 comes from here, factoring by grouping. The last ones, these are formulas, and you'll get used to these formulas. We'll do some examples with these. If you have binomials a to the third plus b to the third, or a to the third minus b to the third, you can factor those. So for example, here, you're trying to ask yourself, what multiplied by itself 3 times gives you 8x to the third? And that would be 2x. And what multiplied by itself 3 times gives you 1? That's 1. So this guy right here functions as your a, and this guy right here functions as your b. So in the formula, for example, a minus b is 2x minus 1. Then you have a squared, which is this squared, which gives you 4x squared, plus a times b, which is this times this, so plus 2x, and then plus b squared, so this squared gives you 1. So it is a formula, two formulas actually, one for plus and one for minus, that you will want to memorize so that you can use these particular formulas. Let's go back up here to the top of the page and we'll go through these examples. So, first thing, get everything on one side so you have 0 on the other side. So here's what I've got. Subtract 3x on both sides. 2x to the third minus 5x squared minus 3x gives us 0. First step, do we have a GCF? Yes, x. Pull it out. And it leaves you with 2x squared minus 5x minus 3 equals 0. So now, how would we factor what we have left? What methods? You could use the box or grouping or slide and divide. Alright, so you could use any of those methods. So if I were to use the box method, I'll just go over here to the side, draw a little box, very little. The 2x squared goes here. The minus 3 goes here. Multiply those and it gives you negative 6x squared. And I want it to add to negative 5x. So how about negative 6 positive 1, right? So negative 6x and 1x. My greatest common factor in this column here is 2x. 2x times x gives you 2x squared. Here 2x times negative 3 gives you negative 6x, and x times 1 gives you x. So your outer terms here give you your factors. So bring down your x. I've got 2x plus 1 and x minus 3 equals 0. So this sets up 3 equations for me. X equals 0, 2x plus 1 equals 0, and x minus 3 equals 0. So x minus 0, that's one of my solutions. Here, would you agree this is going to give me x equals negative 1/2? Yes, subtract 1, divide by 2, and this one will give me x equals 3. Okay? And there I have solved my polynomial equation. All right? Let's go ahead here and try the next one, example B. So let's subtract 6x to the third on both sides. And I've got 3x to the fourth minus 6x to the third plus 12x squared equals 0. Do I have a greatest common factor? Because that's always step 1. 3x squared. Which leaves me with x squared minus 2x and then plus 4, right? These are easy. What multiplies to 4 and adds to negative 2, right? Doesn't work. What else can I do to find those solutions that I learned in my unit on quadratics? We can do completing the square or quadratic formula. And I'm sure out of those you all prefer the quadratic formula. So let me tell you one thing. For right here, you've got 3x squared equals 0, which means x equals 0. All right, that's one solution. The other one is x squared minus 2x plus 4 equals 0. Quadratic formula, a equals 1, b equals negative 2, c equals 4. Let's go ahead and we find that x equals negative b, which is 2, plus or minus the square root, b squared, which is 4, minus 4 times 1 times 4, all over 2 times 1. So in here, this is 4 minus 16, right? Negative 12. So this equals 2 plus or minus the square root of negative 12 all over 2, right?
Yeah.
Oh, we're going to have imaginary numbers. So this, would you agree? Square root of -1, square root of 4, square root of 3, right? Split that baby up. So this is 2 plus or minus 2i square roots of 3 all over 2. And I see that we're going to be able to factor out some 2's. Factor out a 2 from your numerator and you get 1 plus or minus I square roots of 3 over 2. Those 2's cancel. And our answer is 1 plus or minus I square root of 3. So, these are two of our answers. They are imaginary solutions. Here is our third solution. That is a real solution. So 1, 2, 3 solutions. Oh, actually, this is a double root because we get the x twice because it's x squared. So the multiplicity of this is 2. So at that point, your graph would not go through 0. It would bounce off. All right, let's go to the next page. Alright, I want to show you something. On the previous page, we talked about the formula for a to the third plus b to the third, and this was a plus b times a squared minus ab plus b squared, right? And you're probably wondering, where do they get that from? Well, it's actually really cool. Let's use our FOIL techniques right here. So I'm going to take a times everything here, which is going to give me a to the third minus a squared b plus ab squared. That's a times all of this. Now I'm going to do b times all of this. So plus a squared b minus ab squared plus b to the third. Okay? Combine like terms. Would you agree? This and this are like terms. And they cancel. Would you agree? This and this are like terms. And they cancel. And what you are left with is a to the third plus b to the third. Where did I get what?
The first thing you wrote, a plus.
This is the formula. It's on the previous page. I'm just proving out to you why it works.
Okay.
That's all. Alright. We've got some more examples. What are real or imaginary solutions of each polynomial equation? Let's go through some examples. These are some weird ones. Subtract 4 on both sides, and would you agree this is what you get? Right? You're not used to having to factor something with x to the fourth, right?
No.
Okay, let's just assume something for a minute. Let x squared be equal to n, okay? Just for grins, okay? So if we assume that is true, could I get you to believe then n squared equals x to the fourth, right? Yes, okay. So this could be written as n squared minus 3n minus 4 equals 0, right?
Yeah.
Okay, factor that, n minus 4, n plus 1. So far, so good?
Nope.
Okay. Let's substitute back now because n equals x squared, right? So x squared minus 4, x squared plus 1 equals 0. So far, so good? you get used to this and you can actually go right from here to here. Oh yeah, you can do it. Totally, trust me. Because the way you get x to the fourth is x squared and x squared, which is what you have in the middle. I'm just saying that so we can substitute our way through it. That's where I'm just saying. Now, would you agree this factors further? Yeah. How does this factor? A squared minus b squared, guys. X plus 2x minus 2. And then I've got x squared plus 1. Does that factor?
X plus 1. X plus...
Do you remember how it factors?
X plus where?
X plus 1, X minus 1?
Remember on the test from quadratics, how does this factor?
Oh, with the I?
With the I!
What the crap?
X plus I, x minus I?
Oh, you're right.
Remember doing that? Yeah. Okay. So, out of this, you have all these four factors. Would you agree this is going to give you x equals negative 2, x equals 2, x equals negative I, and x equals I?
Why did you say negative I? Wait, why did you make the x squared plus 1 the i's?
Remember, a squared, go back, a squared plus b squared equals a plus bi, a minus bi.
Where was that? Be myself.
It was in our unit on quadratics, section 4.8. Okay, let's go to B. Get everything on one side. That's always your first step. And I have x to the third minus 1 equals 0. What formula do I use here?
You don't.
Oh, you can go into 3. No.
What's the name of the formula? Sum or difference of cubes. I don't know what the bottom line is. Say what it is. Sum or difference of cubes.
I just in quadratic, you're like, no, get a quadratic form.
No. So, this is x to the third and 1 to the third, which gives us x minus 1 times x squared plus x plus 1. That's from the formula. The formula is a to the third minus b to the third equals a minus b times a squared plus a times b plus b squared. It's on the page previous. Alright? Would you agree? Right here, this is going to give me x equals 1. Okay, this isn't going to factor. Quadratic formula it out.
Alright, why is it a factor when it's the actual?
What multiplies to 1 and adds to 1? Adds to 2.
It doesn't work.
A equals 1. B equals 1. C equals 1. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Right here, this gives you 1 minus 4, which is negative 3. So, negative 1 plus or minus the square root of negative 3 all over 2. Would you agree this is I square roots of 3? So this is -1 plus or minus I square roots of 3 over 2. So there are your other two answers. All right? Let's go to C. C is a lot of fun. Okay, move the 16 to the other side. X to the 4th minus 16 equals 0. Difference of two squares.
X squared minus 4. X squared plus 4.
Yes. Okay, go again.
X plus 2, X minus 2.
And what is this?
You have all of your things.
2i?
Yes, x plus 2i, x minus 2i. Okay, this gives me x equals negative 2i, x equals 2i, x equals negative 2, x equals 2. That wasn't bad. Okay, last one here. First thing, distribute, get everything on one side. So I've got x to the 3rd plus 8x equals 8x plus 8. When we move everything over to the left, would you agree I've got x to the 3rd minus 8 equals 0? Okay. This is x to the 3rd and 2 to the 3rd, which means you're going to use that difference of 2 cubes again. That formula. So here's what we're going to have. X minus 2. Then you start with a squared, which is going to be x squared, plus a times b, which is 2x, plus b squared, which is 2 squared, or 4, equals 0. All right? This part is going to give you x equals 2. There's one answer. This part, nothing multiplies to 4 and adds to 2, quadratic formula it out.
Oh my God.
So a equals 1, b equals 2, c equals 4. So x equals negative b plus or minus the square root. B squared is 4 minus 4 times a, which is 1, times c, which is 4. This is 4 minus 16, which is negative 12, over 2 times a, which is 1.
4 and 3i.
Okay, go to this guy right here. You're going to have to simplify. Square root of negative 1, square root of 4, square root of 3. Negative 2 plus or minus 2i square roots of 3 all over 2.
Negative 1 plus or minus I squared of 3.
There you go. All right. The last thing I want to show you is how to find the zeros of a function from graphing. When you're doing this, the first thing you're going to want to do, get everything on one side. So I'm going to minus 4x squared on both sides. And I'm going to subtract x on both sides. And I end up getting x to the 3rd minus 4x squared minus x plus 5 equals 0. All right? So you want to get your graphing calculator out. Okay. Here we go. Go ahead and put this expression into your y equals. So I've got x to the third minus 4x squared minus x plus 5. And go graph that and see how much of it we can get on our graph. Oh, lovely. All right. We got all three of our zeros, okay? Which is fantastic. This works just like it did with our quadratics. So go over to second calc. You want to find your 0. It says left bound, so I'm going to do the first one. I just want to be on the left-hand side of that 0, and I'm going to click enter. And then it says my right bound, so I want to go over till I'm on the right-hand side of it and click enter. Then it says guess, so go sit on it as close as you can get. Click enter. And it's negative 1.09. Okay, so there's one of them. Let's go do the next one. So go back, get your 0. It says left bound, so go somewhere on the left-hand side. Click enter. It says right bound, so go to the right-hand side. Click enter. Then it says guess. So go try and sit as close to being on top of it as you can and click enter. And I've got 1.16. All right, so that's the second one. Now I'm going to get that third one, so I'm going to go back to calc, find my 0. I want to be on the left-hand side, there we go, of that 0. Click enter. Now it says right bound. Go somewhere on the right-hand side of it. Click enter. Go try and sit right on it. There we go. That's where it says guess. Click enter. And I've got 3.93.